Welcome back to the stream, folks. Unlike most streams, Tuco the cat is not on the rack. He is digging into some kibble over in the kitchen. So, this will be a fairly straightforward stream. I was just doing some more CAD. There's been a lot of CAD, lots of CAD. Oh, I'll stop here. So, lots of CAD. We have been working on a new version of this piece, and there's a lot going on, but overall this is still part of the project we've been building to do kind of a flying camera. So this will be pulled around on nylon cords. There will be a camera on a gimbal at the bottom. This is pretty much ready for assembly. I've just been working on CAD lately since that's been I think that's the next thing that's holding up the project, because I need to design the actual winch pieces so that I can print a bunch of them. Well, 4 of them total, but it's a lot of printing. Each one of these is probably like a few days of printing total. Hey Tuco. I think Tuco the cat might have eaten enough kibble and now he's on his way back. Hey Tuc. Oh, he's gonna be prowling. See, this is why we need the robotic camera, so that we can pull it around with a joystick and follow the cat pretty easily. So anyway, we were working on a new version of this spool. So this is the second spool design. The first spool design was a kind of vertical design. Actually, let me grab that for side-by-side comparison. Oh, this one's got some stuff attached to it, but let's detach that. Okay. That's a lot of plastic. So, this was the first spool design. This one did not work very well. I was really worried about it being strong enough to hold together all these disparate parts, and so I kind of engineered this big chunky backplane for that. But the actual spool was only supported by the motor itself. I was just hanging it on the motor shaft. I thought that would be okay just based on, it seemed like the motor had a big old chunky shaft and maybe it could handle that. But that was a problem for a couple of reasons. It turns out in this design, the weak point was really just the spool, due to problems I could have fixed in the spool design. It was way too easy for these two halves to come apart, and I was relying on having this side attached directly to the motor shaft, then supporting this side somewhat with another kind of pin in this bearing. And so that would have been riding on 2 bearings, so 1 bearing here, then another bearing in the motor. We found out later that the motor has 1 bearing on the front and then a bushing in the back. But yeah, there were a few problems with this. Really, this relies on just the 3D print layer strength and the glue bond to hold the spool together, in compression. So by filling it full of cord like this, even if the glue joint wasn't the weak point, which in this case it seemed like that was the problem, even if the glue joint hadn't failed, I would have just fractured the plastic somewhere else. So the new spool design, much thicker to avoid this bending as the spool loads up. And now there's a bolt actually holding all the layers together. So, much thicker. It's now in 3 pieces, so I have a flat bottom on here, a center piece that actually has kind of a castellation pattern on the top that hammers into this gear. And then the gear is actually built into the other side, so this other flat piece here. Oh, I'm just catching up on chat a little bit. James says, it's somehow a lot taller than I expected. And is this the motor with the wonky shaft? Oh, is this how the motor with the wonky shaft got a wonky shaft? As far as I can tell, that one was just damaged in shipping or something. But in fact, we actually took that motor apart and looked at the run out, and it was barely noticeable. So I think maybe we were getting some of that amplified by kind of a bad coupling between the spool and the motor. So it was probably a combination of factors. It was probably a little bit of wobble in the motor. It was probably a particularly bad joint. The other motors do seem to be better, but even the one that had the kind of run out that looked bad is probably usable in most applications. So it's probably fine. I learned a lot from that design, and this fixes a lot of those problems. So the first design had this kind of flimsy spool and this back plane with the spool mounted directly to the motor mounted on the back, and then all of these sensor doodads up top, kind of all sharing the same back plane. So big ol' idler, smaller idler, capstan, another small idler on the load cell. So that seems very simple by comparison to what I'm working on right now. I'm kind of lamenting these days, but I feel like mechanically the new design is going to be so much better. I didn't have this like shell that fit over the whole thing. So this shell was problematic because it was mostly aesthetic and dust cover and keeping cats and fingers from getting stuck inside the thing. But it also had a structural job to hold that center post in the bearing. And so you can see some reinforcement here, but that turned out to be not nearly enough. So that was another problem with that. So this design is shelved. I've just been scavenging parts from it. You can see how these two pieces fit together though. Then the next one, I did this, which wasn't meant to be a full, this wasn't meant to be like a full winch design. This was just like a trial design for testing out some features. Really, the thing I was concerned about testing was this idea for using soft gears to give me a quiet run. Unlike, I didn't want the metal or the plastic gears that kind of hit together as they mesh and then cause a little clack that then amplifies, and now you have a noisy gear train. You can certainly mitigate that with plastic gears. You can break them in, you can lubricate them well, that certainly helps. But since I didn't need a super high amount of torque, and I actually have a decent amount of size for chunky gears here, I thought I would try using softer materials to deaden the vibrations there. And so this was a test. I used NinjaFlex, which is the softest material you can usually print in. And I made just a little rim for kind of an inner spline that actually drives the spool. And that was all right. That actually worked well enough that I started making a modification of this design to just sort of fix all the problems and turn it into a real winch bot. So I ended up making some relatively fundamental changes that caused me to backtrack on the design a lot, including I doubled the height of the gears. I fixed this problem where I wasn't using the right length of M8 shaft in my CAD model, because I intended for those to be 100mm, and in my CAD model they were 75. And I added a lot more clearance around here because this was scraping a lot. And then, as I already mentioned, I made the spool itself a lot sturdier. So this spool is, I think, probably plenty strong enough, whereas this one was pretty flimsy. It takes a lot longer to print this one, but at least now I know it's worth it. And so this one, well, I already explained that it's like a bolt in 3 pieces. This is the other piece that it goes with, the partner herringbone gear. And here I've just assembled the... So this time they're wider. They're also made out of a slightly less flexible material. So it's semi-flex instead of NinjaFlex. Let's get a card in the camera. Oh yeah, Jonas says, I really needed a stream today, thanks. Well, you're welcome. I was feeling kind of the same way. Things were feeling kind of depressing in the world, and just designing some stuff and sharing it helps. Especially when designing stuff by yourself gets a little monotonous, because that's what I've been doing most of the time. Yeah, so here's our spool so far. And right now I've just mounted it with nuts at the end, but actually there's room for bearings on either side. So the bearings, I mean, I can go ahead and put those in there for illustration, I guess. I already put my wrench away. I already put the wrench away. I think it would be fun to spin the spool at least, so let's put the bearings in. I think the way this actually assembles is the bearings get pressed into the piece that I'm in the process of designing right now. And then the center shaft probably fits into the bearing pretty easily, and I need 2 wrenches. Oh, that's right. I have a socket right here. I had these 2 nuts jammed against each other. Now the space is too narrow for my crescent wrench. I can make it wider easily. I can't get any of this on camera. That is the driver. Tara asks, is the biggest change to the spool the thicker sides? Yeah, I mean, the thicker sides completely, I mean, the sides are also sloped so that they're thinner at the edges and thicker in the middle, whereas the previous one was just uniformly pretty flat. A little bit more reinforcement between the gear and the spool. New mechanism for joining the center and the edge. There's this like hammer-in T pattern, which is really nice. I think it turned out really strong. What else? Yeah, those are the main differences. I mean, the previous spool had the same thing where there's like a cancellation in the top, but I redesigned that pattern so that it's, well, A, it's easier to assemble, you just hammer it in, and B, it's actually really strong. I think I got the clearances just right. Oh, and I made this hole smaller, because on the other spool that was a little too big and the knot was passing through. So... that takes a 608 bearing. I mean, the best kind of assembly is the kind of assembly where you have no surprises, right? It just goes together right like the CAD model says it should. I sat next to a bunch of mechanical engineers at one job I had, but never actually really did any mechanical engineering. Oh, I think the threaded shaft is a little bit tight against that side, but there we go. There's a couple of places where it feels a little tight. Maybe this shaft doesn't need to be. I feel like something's a little bit weird between the bearing interface and this plastic, like maybe there's something stuck up off this. Yeah. I think some of that is just the resistance from the grease in the bearings, but I might have been feeling a plastic booger catching on the bearing for a sec. Oh. Is this something where one inner race is a little wider than the other and I have to be careful about how I attach the nut or the nut will drag on the bearing? I think that might have been the nut dragging on the bearing shield. I'm gonna have to be careful about that. There's a way to assemble it where it's fine, but there's also a way to assemble it where the bevel on the nut doesn't clear the shield on the bearing. That's annoying. Okay, well I think I assembled it properly now. And I can't hold that also, but I'm feeling a little bit of wobble and a little bit of friction on those bearings. Oh, you'll also notice there's some, so this plate did not print correctly. It actually warped, but it was good enough that I kept it, but you'll see that in the rotation for sure. This plate worked out fine, so that's what it would look like if I had preheated my printer long enough, probably. But other than that warped plate, which I don't think will be a problem, it'll just look kind of weird. And there's a little bit of friction in these bearings. I don't know if that's going to be a problem. But yeah, I think this is all right so far. A couple of things that might be a problem, things to keep an eye on, but it's looking good so far. So I think we can get back to the CAD design. That's what I was mostly working on here. Okay. Here we are again. Jarrett says it looks weighty. It does seem pretty weighty, huh? I guess I could weigh it. Let's weigh it. Of course, I just put bearings on it. Oh, Tuco's on the rack. I should move the camera. I'd be all over petting him right now, but I've got bearing grease on my fingers. All right, 0 grams. Yeah. I mean, so there's some metal parts in there too, but yeah, 290 grams. About 300 grams, actually. What was that like without the bearings and nuts? It's a little annoying to take out the actual linear shaft, but I'll take these out at least. Okay, 270 grams, and how heavy is just one of the shafts? Only 30 grams, so yeah, most of that's plastic. It feels like a lot of it's in the gear side over here. This, yeah, it's printed with a lot of shells. Fairly normal infill, but thick tops and bottoms and everything. It is beer o'clock. Beer o'clock as I hit the beer against various objects. Yeah. Alright. So this has been, oh man, this has been so much work to model. And it's the sort of thing where I wish I was enjoying it more, but still haven't quite gotten to the point where I enjoy using Fusion 360. I don't know whether I should just keep using this because it's, you know, the program right now, which is both powerful and accessible to hobbyists, so it's in that way kind of useful to share, but like I don't, like, you know, you've heard me complain about it a lot. I don't really necessarily like it that much, and it's, you know, because of the position Autodesk is in, I don't necessarily want to invest time and resources in making it better, whereas different programs maybe I would. So I should maybe, I mean, I'll probably do the next design in something else, or figure out a different way to use this that's less frustrating. But preferably figure out how to start doing some more advanced modeling like this in free tools. Like actually free, not software as a service. So anyway, a lot of what I'm doing here versus the previous spool design is managing reducing the torque on this mounting bolt and keeping the weight roughly centered below it, mostly just to make mounting easier. If I have a big heavy thing off to one side, then it makes the wall mount bracket a lot harder to design well. Whereas if I have a mounting stud above the heavy thing, the weight is mostly added without, you know, vectoring left and right that much. It's mostly more stuff below here on the spool. And then the force vector, where the cord coming out of here is kind of pulling up toward the ceiling, that is in line with the line from this stud here to kind of the center of gravity, which is going to be down here somewhere. So with all that, I hope that, you know, this thing kind of wants to stay lined up where it needs to be on the wall to some extent, rather than kind of constantly trying to fall over. So it'll mostly just make it more stable with less mounting. So whatever mounting I come up with, it'll be more stable, and I'll need less mounting to achieve the same amount of stability. So that was the main thought with this structure. This also needed to change a lot to support the spool really well on both sides. So that's why I have this kind of big chunky C-shaped structure. So down here, I'm mounting the motor. I've got more of these M8 studs going up through here. The nut up here is right there. And that just connects the two halves together. These are printed with the grain of the printing going horizontal, so that the layer boundaries stack in the axis that's vertical right now. So you can imagine each little layer kind of acting as a loop around this nut, or like this bolt rather, and this bearing, and this bolt that you can't see under here, and these bolts that you go through here. So that's providing a lot of the strength, binding all of this together. And then this bolt up here, mostly that's holding on by this really wide area of interlayer adhesion. So I am relying on the layer adhesion there to hold this thing up, which is not amazing, but it is reinforced somewhat by this bolt, which is holding this roller on, but not a ton, since that's just pressing on the small area below the bearing. I think that'll be fine, but that's one area of concern, is will this bolt be strong enough? The other thing is the reason I've not actually started printing these yet. Well, I started printing this bottom piece because I thought I had it at a point where I could use it for testing at least. And, well, I had a printability problem. This angle right here was much shallower. And so even though I was printing with support material and it was building up, you know, up in this direction, it was making such a shallow overhang that that little layer of plastic would curl up and then hit the print head, and then that hit would then cause it to get offset. So then, you know, I'd get the rest of the print printing a few millimeters off from where it was supposed to be. So fix that by changing this angle here. But because of that print failure, and I was already thinking like, oh, maybe I should modify this bottom piece to give me a place to mount this roller. And so then I just went kind of back to the drawing board and added a bunch of this design for the roller. So that's a lot of what I've been doing the past day or so, is modeling all of this stuff to get the cord from the spool up to the measurement assembly and out. So just to give you a little kind of a journey of where, like, how the cord actually flows through this thing after it's on here. So to start with, let's say the cord is knotted on that side of the spool. Goes through this hole, around the core of the spool. Then it goes through the space between this roller and the side of the enclosure. The space here is for the cord. And so you can see, like, if we're looking through that space, it needs to be clear. And this is a little tricky because this whole thing is curved. But it needs to have a clear path. Whether the spool is empty or full, that angle can vary, and it needs to make it onto this roller. And then likewise, the spool is going to wander around side to side, but we want some amount of restoring force to pull it kind of toward the middle so it doesn't bunch up at just one end. So previously we had an idler that had a shape that did that. This time I'm doing it with this combination of rollers. So these two rollers serve to constrain the cord in about 2 axes. So it'll come through and get kind of centered here. Then it'll pass over both of these rollers going up. Then over around here, around this roller. Then under this first roller, which holds it down so it doesn't escape, off this, for example. And then over this next roller, which presses it against this capstan, which needs to reliably turn against the cord because that's how we're measuring it for servo feedback. So the cord goes over this roller, then under this capstan, then in a straight line parallel to the load cell, so we don't end up measuring the force on this part of the cord. Then under this idler, then straight vertically out there, perpendicular to the load cell. And then that probably just goes directly to a pulley on the ceiling. I might have another set of rollers here to make sure that this stays lined up, but the main plan is to angle this so that it's pointed directly at the ceiling pulley. So I'm not sure if I'll need those rollers, but that's something that's still an option. So that's what we've got so far. This is just getting really complicated, and there's a lot of stuff here I haven't tested, so I keep looking for, where can I cut this design? So these parts are done, and everything else that I can design later bolts onto this in a way that doesn't require modifying it. So I think I've almost reached that with the top. So here, I really needed to build the supports for this roller into the top and bottom, since they really needed to be in that same plane with a lot of the same support as the center here. So they use the same kind of mechanism where there's a section of M8 threaded rod with a 3D printed roller over it, 2 608 bearings, and nuts. And the nuts will spin with the roller. So the way you'll assemble this is just like the spool. You'll press the bearings into either half, bolt the 2 halves together with the roller in there, and then secure the nuts on either side. Maybe put a dab of Loctite on the nuts. So that needed all that support. And then thinking about these rollers, I was really scratching my head trying to figure out how to actually support these rollers properly. But the way that this is designed, I think I've got it. So, well, actually, even just starting with this first roller, you can see that as the cord comes across there, we're mostly relying on these same loops with the grain of the print. We're cheating a little bit because there's some of this that has to bond to some of that. So we're going down a little bit, relying on the layer bonding here. But for the most part, we're dealing with the print in its strong orientation. And this is also mostly compression, which the print will be pretty good at dealing with. So if you can imagine tugging on the cord, it's going to be forcing this roller to move toward, to want to move toward the roller, or toward the spool. And these pieces of plastic can pretty easily deal with that load. Then the next rollers here, this will also be dealing with compression, but in this case, that direction for you guys. So in that case, this print, so now we're dealing with the print in the weak axis because this is going to be part of the same piece. But because we're just compressing the layers together, I think this will actually be plenty strong. So this is just compressing layers, trying to kind of pull this roller that way. Same with this roller is trying to be pulled this way. And we're supporting both of these rollers by these wide cutouts on the nut and the bolt head. And I think that's easier to see in section view. Yeah. So these are both the same assembly. Two 608 bearings, 3D printed tube around the outside, 3D printed spacer in the middle. And that's because, you want to be able to tighten this all the way without loading these bearings axially. So this tube takes the compression force from the screw, and then this tube is actually what the cord rides on. And it seems a little silly using two bearings for like such a short roller, but I think it would wobble too much if I designed this with one bearing. So this one up here uses one bearing, but most of the rollers have to use two bearings. So I ended up designing those supports and then kind of merging them in with this top piece and trying to, so there's more support in between here, but it's also cleared such that the cord can freely go between these pieces. So that took a lot of modeling, but I think I'm pretty happy with this result. You'll also see this cutout here so that there's clearance around the spool itself. Bolt head encroaches into that just a tiny bit, but I think we're fine. And then we get to the top. Let's actually, if I show that without the rollers, you can see just the plastic features. These come right up against the bearing. And then that's access for tightening the nut for this roller. And then another roller up here. Pretty simple. Spot for a bearing. And I have to turn off the spool to see it, but there's a place for a nut in the back. So that gets us to this next section. And I've been calling this the top rollers, yeah. All right, so this is what we're working on now. So I just made this and anchored it to the top. And then I designed these rollers. I have not designed a mount for them. And I was thinking about how to do that. If printability were no object, I could just join these to the top and that would be fine. But the way this is printing, this wide flat surface is on the print bed, and everything that's off of that requires support. So I'm printing support material under here, and under here, and under here, which is fine, but then if I add a little bumpy thing here, and it's not just these two rollers, it's these two rollers and this encoder need support still. So if I were to add features for all of that and still print it the way I have been printing it, well, now I've raised the floor, and the floor of the printer is now down here, and all of this needs to be support material, which is a lot more wasteful and makes it a much longer print and more likely to fail. So, and then maybe there's other print orientations. I've been avoiding printing it like this because that doesn't give me the strength that I want for these pieces. It'll just split apart right where the bearings and these bolt holes need to be strong. And the other direction, I have another kind of monster support problem where I need to put a lot of support under here. One thing I've been considering is separating these legs from the rest of, from like the top and bottom. I think structurally that wouldn't be awful. It wouldn't be great, but and if I did that, I could potentially print this as the floor. Then I would need to fill in support here below the bearing, but that's not very much really, and some in some of these holes. That's not a big deal. But I don't know if I like that structurally. The solution I've been leaning toward is to keep this piece pretty much intact, because really what this represents right now is mounting for all of the really structurally critical parts in this. So, like, this roller is changing the direction of the entire force this winch is dealing with. Same with all of these rollers. I mean, these maybe less so because they're just kind of compressing inward, but like this has got to be strong. This roller has to have support, as I mentioned, in pretty much the same way the spool does. And the load cell over here is the other kind of major thing that needs support, because this has to cantilever and support the entire weight that the winch is dealing with. So these screws go all the way through here. But this top assembly is just for measurement. These rollers are for alignment. They'll be experiencing, you know, a little bit of kind of side-to-side force, but they aren't changing the direction. They're just, like, imagine that this support came loose entirely. You know, these rollers would end up getting kind of twisted out of the way a little bit, but they wouldn't just rocket off sideways, like, for example, if this lost its nut. Same with the capstan. The capstan is intentionally not under a lot of force. It's just experiencing a little bit of pressure upwards here, but not really that much. So what I'm thinking about doing is making another piece that mounts these two rollers and the capstan, and then attaches to this whole thing with long, relatively small screws, so maybe like M3x40s or something like that. So if that design looks like, if that idea seems like it's going to work out, then I think the first thing I do is I start with the fasteners and see about how they attach to here. And if all that looks good, I can even put off designing this actual bracket. I can just move on to something else that affects these pieces that I want to get into the printer next. And as far as other modifications I want to make to these before I can actually print them, mostly I'm thinking about how to mount all of the electronic parts here, which again are pretty light. I can just figure out where I've got some free space and put some places for M3 nuts or whatever. So these are some parts that we have not placed yet. There's a DC power jack, there's a microcontroller, there's, intersecting each other, a load cell amplifier and a motor H bridge, and then an on-off / emergency stop button. I think that stop button maybe goes right on the front here in front of the motor. Also, I'll want to put a shell around this whole thing, mostly to protect it from, you know, cats and humans sticking their limbs in here. So this flat back here is actually kind of load-bearing. This presses against the wall mounting plate. So some of that might end up wanting to be exposed, but then a shell that actually covers pretty much all the other sides. And so that'll probably end up wanting to be a two-piece thing, pretty thin so that it doesn't take forever to print. And that'll want to have some pillars that come down and meet this in a few places to actually attach. So I want to keep that in mind. Think about where I can add mounting for the shell. And it's certainly possible that I just end up wanting to put the electronics on the shell, since that gives me some flexibility to design that part later. It also gives me flexibility just to put the electronics in more places without having to, you know, worry about the printability and structural integrity of the structure everywhere I do that. So I think let's add some hardware next. Top rollers. Oh, James says make the cover transparent. That's a good idea. I didn't make the previous cover transparent. You know, I guess I could vacuum form the cover. And that would allow me to make it larger, much easier than if I was printing it. I mean, if I was vacuum forming it, it'd probably still be vac forming it out of... Like, I'd want some way to CNC the mold. So I'd probably either borrow somebody's larger CNC machine and make a mold out of wood, or either 3D print or mill a few smaller pieces here. Like, I could 3D print some large, like very, very low infill pieces to use for the mold, and then make a vacuum forming rig here. But yeah, I like the color on this piece. Because if it was transparent and 3D printed out of transparent filament, it wouldn't really be optically clear. You could kind of see stuff moving around in it, and you could see the lights on the circuit board, but you couldn't really see the inner workings clearly. Alright, what am I adding? Actually, what is this distance we might want? Like the longest thing that we have here is from down here up to, well, we're going to want to go up here really, but I just want a reference point. What is this? So that's 37. Yeah, what is the longest M3 I have handy? I think I've got a bunch of M3 by 40. I mean, I've got these, but certainly don't have to be limited to just what I have in stock. But I have a lot more M3 by 35s. I think 40 is unnecessarily long because I think it's just going to be ineffective past a certain length. Yeah, I've got plenty of M3 by 35s, and that seems reasonable. Let's just insert some of those. Going with the Venn diagram intersection of what's convenient and what seems structural. Why are all the windows so small? I really want to make this... Oh, can I make this bigger? Is that new? I thought I tried that and it didn't work a while ago. I wonder if that's new. Well, that makes me happy. I was used to the McMaster car browser being the tiniest window. It still has all these weird scroll bars. What? Oh, I got the non-metric filter somehow. Actually, the ones I have are stainless. I might as well get the 3D model for these. M3 by 35, partially threaded. Alright, I need a little warning, like a little button I can press when it's frozen that just flashes 0 FPS. Man, Tuco sure is backlit. I'm gonna see if I can do something about that. This time the weird smell in the shop is definitely the neighbors cooking. It smells like something that would be pretty tasty. I think it smells like meat, but I don't know. People seem to like meat, I guess. It seems weird. All right. I guess I'll make a sketch up there where I make some mounting holes and then line up the screws with the holes. I'm thinking about this piece maybe wanting to be kind of a flattish thing. Like imagine the print bed right around there. And then I have, you know, some screw heads maybe hanging out around here. And where else? Is there anywhere else I can put a screw? Maybe I should put them down here. And then this could even be a separate piece. This could also be something I print. Same orientation as there, with kind of a bridge at bottom and two arms that come up. It would have to be pretty tall to clear, because the cord, remember, is going down here, above here, then down there to the capstan. So it'd be nice not to have anything above it. So maybe two separate pieces is what to do. That's simple. Then, all right, let's just do that. So I'm in the top rollers component, which sounds like something from Vegas. I'm the best at rolling. And so I'm going to do the screw holes for both sides, even though they're going to be two separate parts, I think. Let's project some references. I've learned that this program really likes if you're pretty selective with what you project. If you project something, even if you don't reference it anywhere, that counts as a dependency, and if you break that dependency later, you've got to kind of sort out the mess or live with a messy design that might break in ways that you aren't anticipating. All right, so now let's just hide all of this. How big are my screw holes going to be? So these are M3, which means the screw itself has a nominal 3mm diameter, if I'm remembering right. There's always a subtlety in exactly whose responsibility which parts of the clearances are. But I think usually I want this to be somewhat wider than this to act as a pretty nice clearance hole, and not jam up in the hole. So let's do 3.35. What does that look like? So we could easily fit that in between there. Just wanted to measure the distance between these two. 0.6mm, that's enough. It's enough for a couple layers of plastic at least. And then similarly, two screws over here. So the two sides will not be symmetric because, well, I guess they could be. Yeah, why not? Let's make them symmetric. Get a center line then. Oh geez, and let's make all this construction geometry. Yeah, that's better. Construction geometry won't accidentally turn into profiles later and cause your extrudes to generate completely not what you want them to generate. So, I assume we want probably 2 screws on each side at least. I'm lamenting not being able to put another screw over here, but that would require extending this base piece over, which I don't really want to do. I guess I could, but I don't think I need to. Maybe a screw as close as I can get it to this capstone. The other side of that will be buried in here, which is not the best place for a nut, but as you can see, I'm already doing that. And then, so thinking about the forces involved here, so these 2 rollers, if there was no support attached, they would kind of try to twist around like that, I think. So we are, at least for the front roller here, relying on the combination of layer bonding and the bolt to hold it down. So having the bolt head go up higher so the bolt's going through more layers would be useful for that. And then you've got the same problem over here where it'd be really nice for the bolt head to be above, for example, this lower mounting bolt, so that, well, I guess what grain am I printing this with? If I'm printing it this way, then that whole plate is already pretty strong. And I can hold it down onto that. Yeah, I think that's just more reason to print it in this orientation. Because if I print this orientation, then the loops of plastic are holding all of these nuts toward the stalk of the screw, or the bolt that's coming up over here. And that's exactly what I want here. Because this capstan is trying to be pushed up away from the rest of the assembly. It's also trying to be flexed kind of in that axis, like that. And so having that piece come down below here is probably really helpful, which will make it a little more annoying to print, but it's probably worth it. I could also print it on this front, in which case I need support material inside these bearing housings, but then it makes this support a little easier. Alright, this is coming together. So that means I do want this screw. So let's project some of these. I care about this face and this face. And I would like there to be a screw kind of in between these 2. That seems like the best place structurally for me to put one of these screws, as long as I keep it out of the way. And it doesn't matter as much how far away it is. I mean, it's stronger for it to be closer, but it's fine for it to be over here, because what I'm concerned about is having that loop of plastic that goes around both, you know, like the top and bottom, and around the nut and the screw, or around the bolt head or whatever here, and around here. So if the bolt head was like right around here, that might be just right. Why is there beer on my table? I think it did that thing where you put it down and it overflows. technical difficulties. Is beer technical enough? I mean, it is pretty important technology, brewing and all. Soaking the very back of my phone case in beer. That'll be nice. Oh man, it would be terrible to have an intern. If I had like an assistant or anybody else helping me out with this stuff, they would just be like fixing audio levels and like laughing at me as I clean up beer. Sorry about that, folks. Oh, I just saw the hi from Ian in YouTube chat, from Ian Bennett, who says, "Hi, Mike Elizabeth Scott." I will say, "Hi, Ian Bennett." Yeah, the stainless hardware is nice. I've got, like, some of the hardware I have is stainless because I got it for art projects where it'd be visible, and then a lot of it is kind of more utilitarian black oxide stuff. I've been using mostly the oxide stuff in this project because I feel like this project is, while I want it to look nice, it isn't really an art project. So I've been saving the really nice hardware for those. Anyway, I probably looked over there because I wanted to take a sip of this. Are you gonna behave, little bubbles? Kinda. Okay, and how much bolt head do I have to deal with here? Are my calipers not here? I mean, I usually cut out the bolt head after I add the bolt, so I can just reference it to the bolt itself, but here I want to try to position it with that in mind. So it's like a little under 6. 6 millimeters would be a generous bolt hole head. It's more like 5.8. I can choose whether or not I care about keeping this hole clear. This hole is for tightening this nut in the center of the spool. I probably do need to keep it clear because with the order of operations in assembling this, I think I need to assemble the pieces. So like anything that requires attaching parts through this top panel, I'll probably want to do without the spool in place. So attaching this to the top and then putting the spool in is probably going to be the order. What are you doing, Tuco? Tuco, what was that noise? I think he was playing with some stuff in the recycling pile and asking to go outside. What a cat. So if I want to keep that clear, then keeping this over here is useful. And then what is... Hey Tuco, you're not going to claw your way through the door. So that can be pretty arbitrarily close. I don't think I need to worry about clearing that. No. Oh. I don't know how to tell him. No. It's too late. I'm not gonna let you out into the hallway. It's like 10 o'clock. Let's try that. I kind of want some bolt hole references for these two. Oh no. Sorry to hear about your headache. Hope that improves. Man, Tuco's really getting on my nerves. He's really used to getting what he wants. Tuco. Uh, 0 FPS and all the meowing. Tuco, no. I don't suppose I can make these equidistant. I'm just trying to figure out where to place this last one. I don't know if that'll work. Let's see what those look like mirrored. That might work. Cool. And so I don't actually need this one, but could put another screw over here. That might actually help. Otherwise, this beam here is going to want to bend up this way. So actually having another screw here might be nice. Yeah, I like that better. So can we name that sketch? Roller mount screws. Yeah. And this is definitely going to have to go in before the capstan is attached. That's fine. This comes off, then you can access these screws. And then that'll come off. So when we look here, we can see the loops that this will be making. So imagine the plastic going around these, and then around that. That's what we're looking for. And then down here, that'll be enough room to cut a nut. Alright, so that's 9 millimeters above the surface. So we need 5 more of those. Just pasting these, which creates references to the same component. So 1, 2, 3, 4, 5. Oops. 5. So here, nice frame rate, guys. It just keeps stuttering and like presumably it's loading something, but then it's like no camera for you. We never heard of multi-threading rendering. Granted, multi-threading rendering much harder than it seems like it should be. So at this point, I could use a longer screw. probably just going to cut the nut hole somewhat deep here because I think this has a decent amount of extra material. This. I don't really want to take this much lower than the midline here, but maybe I could go close. Like, if you imagine the load-bearing part doesn't really have to hold much more than just a little bit of the top part of the bearing. What does that look like on the bottom? That looks better. I don't mind drilling a hole through there for the nut. It's not going to take material out of anywhere that's really critical. Okay. So that is 17 millimeters. I think we're going to use that height for all the rest of the screws. You have to select the right kind of object. It has to be a sketch profile, not some other sketch object. No. That. Oh, yeah. So this will probably print along this axis, this plane being the base of the print bed. Then, yeah, probably same deal over here. So nuts, and then we can design the profiles for this top bracket. We could also design that part later since, like I was saying earlier, I'm trying to get these pieces into the printer. So designing parts that we can print separately is something I can put off for a little while. I don't know if I have any M3 nuts to pilfer. I think we need to insert one from McMaster. Yeah, Tuco is really good at making those meows push the human buttons, or at least he pushes my buttons. I love letting him play in this hallway, and a lot of times I'll go out there and play with him, but usually when it's really late at night, I don't want to let him do that because, well, there's usually nobody else out there for him to play with, and at some point I'll want to go to bed and I'll have to go track him down. And it's just a bit of a cognitive load that I don't always want to have to deal with. You know, trying to relax while the door to my shop is open is not always what I want. Alright, I need a bunch of these too. 6. I've not yet figured out under which circumstances it will save the offset that you so lovingly set, and when it'll just ignore it and use the one you set some other time. Maybe typing it in saves it and selecting it from the drop-down doesn't. Maybe that's what just happened. Tuco, did you find a bolt? These bolts will also, to some extent, hold some of the plastic layers together, which will be nice. Alright, so now some modifications to this frame piece. We can use this same sketch, but now cut into the frame, I think. For this, I think we want to back out to the frames component. Hey Tuke, you found something, didn't you? Oh. Oh, that should have been a construction line. Oh well. Don't cut my bolts. Okay, so I've got to uncheck all the things I don't want it to cut, but the important thing is that it's cutting through this frame idler half 3, which is the piece we're interested in. And then we can finally see our whole pattern and how it relates to the bearing here. Right, and then we will need 2 different sketches for the nuts because they're at 2 different planes. With my wobbly Space Mouse driving, you can't quite see those clearly, but when I actually lock it on there. All right, so frame, sketch. Oh man, I have done this so many times, projecting all the sides of the nut and then offsetting them. It doesn't work very well. There are some nice features, I guess, to automatically chain. Oh man, can I do it that way? I don't know, I'm imagining like, oh, are there different ways I can draw boxes around this to select just the faces I want, but like, it just causes a mess if I project too many things, especially if I project the screw threads, because then there are lots of places for those to just kind of accidentally create dependencies or constraints that I don't want. So this seems to work, but then this seems to end up giving me all these I think these are actually a couple of stacked line segments, such that when I offset them, sometimes I get little like closed loops that loop in on themselves, and sometimes, well, and they never chain together. I mean, we'll get there. I guess I'm jumping ahead. And then of course, every time it actually projects, you might notice that it just like stops for a fraction of a second, which is not fun, especially when you're driving. The Space Mouse is not responsive, it's just the worst. Hey, Tuco. Little cat's brushing up against my leg. Hey, little boy. I call him boy a lot, although I'm sure gender must be pretty weird for cats. Especially cats who don't have testicles, even though they usually would have, you know. There's your bolt noise. It's like flying through dense fog or something. Going through a slow portion of the model here. Okay, so that's our 6 bolts, 3 on each side. We don't care about the holes because those have already been extruded. Now I'm going to mark all of these as construction. Actually, I think it's easier if I don't mark them as construction yet. I do want these to end up being construction geometry, but I think the way to do that is to just mark one of them as construction later. Because here I'm offsetting them. It doesn't chain automatically, so I have to click them all. It also copies the construction versus non-construction status. So say I make that 0.3mm offset. Now I have these 2 separate closed areas, and I actually only wanted one. So I'm just going to select just a few of those and make them construction, so now I only have one. And that's the procedure. Isn't it straightforward? Especially when you forget which side is forward and which side is back and lose the ability to drive. So what if can I do this? See, if I select all those and then offset, it just doesn't work. And if I use chain selection, which is the default, then I get stuff like that, which is not helpful. Oh, what? Thank you. Is this the same problem or a different problem? So many DLLs. They were using cute. This was the same code it crashed on last time. There's also a write of 1 0 byte into R11 with a non-zero bad address. But I didn't look into it any more than that. There's the stack, if anybody from Autodesk is watching. wonder how recent the autosave is. Are you just not ready yet? Or do I have to also close this window? Okay. What do I have in the timeline? Yeah, we don't have any of that sketch, I think. I think we just have the holes for the bolt. Okay. Oh, I guess I shouldn't have been putting this nut on there. I really only want to do 5 nuts on this sketch. That's fine. I'm in the right component. No. I need a virtual turntable. I can just spin the model continuously while they work on it. The trouble is every time I touch the model, it freezes. Okay, 1, 2, 3, 4, 5. This one's not quite done, and then the other one I'm saving. Oh, and saving is so fast. I mean, it could be worse. It's not like saving a 100 megabyte Photoshop document in the 90s. There's also a great failure mode where if you click on the curve instead of the straight part, then it'll project that for you, hopefully, but then it will, or will it? I haven't really gotten a hang of the rules for when it projects things for you and when it won't, because it seems like sometimes it does, but then sometimes you've got to project it manually. And the automatic projection kind of works, kind of gets in the way. I need to figure out actually how that works. Because like here, let's try to use it. Let's delete one of these that I projected. Let's offset. See, I can't select it. Or at least it doesn't highlight. If I click this face, nothing. If I start here, yeah, okay, so that doesn't auto-project. Some other things seem to, though. I don't know what the difference is. Oh, where did that go? Does it think that's already projected? Fine, I guess I'll just add a line. could just mirror two of those. I think for dependency graph's sake, I'll just do these offset though. Oh, really? I didn't want to project that. Fine. Okay, well, a couple of those should have had some more things marked as construction lines, but that's another solution. We'll just select more things. Hey, Tuco. So let's not cut these. Let's cut the frame. Big old deep holes for these. It's a little hard to tell that that's only cutting the frame, but it looks like we're good. Okay, one more for this. Cat on rack. Now there's this other face in front of everything that I keep accidentally selecting. No. See, that... Oh, no, that's not what I wanted even. I didn't even want that profile. I was trying to deselect it when it crashed. Apparently the rule is never deselect anything. Just, I guess I saved it myself pretty recently. Never deselect anything, just kill the whole operation. Dangling pointers and all. Alright. Where were we? We had just extruded those, had not yet started the sketch. Alright. Oh, I need to get in the right component. Top rollers. No. Oh, this program makes me need to sneeze. Oh. I guess this was extruded, or this was projected automatically because that's where I started the sketch. Oh. Okay, only cutting the frame. Cool. Oh, pardon me. Okay. Let me get some more of this stuff out of the way so we can see what's going on. Alright, so this is the frame half that we've been building. Kind of pockmarked here with little holes for the nuts. I guess the thing to do now is to consider placement of more components we haven't looked at yet. I mean, besides saving, of course. Yeah, that's the whole thing so far. Where's that? Alright. I find it really annoying that when you highlight a joint, like normally when you highlight something over here in the real world, there's a little dashed indicator showing you where it is. So like, for example, if I highlight this, it's like, oh, it's in the measurement assembly, and you can follow that down and like, oh, it's in the encoder capstan, it's in the shaft, it's the shaft encoder, great. But if you click a joint, I don't see the same thing. So I just have to kind of exhaustively search through here for, so I think that was actually in, was it in here? No? I was just trying to change its visibility. I guess you can right click here. You can also find in browser. That doesn't seem to have actually done anything. Well, I can... Did that work? I don't think the visibility control worked either. Huh. Oh. Oh, I guess that's right. It's always visible when it's selected, and it doesn't seem like it had any indication that it was selected but not visible. Okay. Whatever. What else do I have in my bag of parts that need to be attached? So this button really wants to attach to the front frame, whatever that is, so I think it can wait. Same with the power jack, it wants to attach to whatever the outer enclosure is. So then we mostly have these circuit boards. The measurement... So this circuit board is an amplifier for the strain gauge, and that might be nice to put near the strain gauge to keep the sensitive analog wires short. The strain gauge wires come out on this side where the kind of weirdly shaped silicone blob is. So in fact, I wonder if the amplifier could just go right here on this surface. Alright. Which side of this is which? Have the one on this prototype still attached. Oh, that's right. We also wanted to add an external electrolytic capacitor here. There's the amplifier. So this side with more pins, it'll look a little wider in the CAD model. That's where we actually have the inputs. We're not using the B channel. There's the A channel, there's the excitation power supply with some external filtering, because the datasheet really recommended some capacitance there that was completely missing on this cheap breakout board. So I figured that would help. So we should include some room for that as well. How big is that? That's like 12 millimeters, 13 millimeters. But, I mean, I wouldn't really let that be a limiting factor because I could bend that upwards pretty easily. Is the back side of that board flat? Mostly, except for the solder. So maybe some little standoffs. 2 millimeters should be plenty. It will be a little annoying that it's only mounted at one side. That's fine. I'm a little worried about wire management there. I don't really know where the microcontroller is going to go. Maybe let's try putting the microcontroller somewhere. What I'm imagining is that this screws down on this side to... Maybe I use heat set inserts for this. It doesn't have to be really strong. And then I don't need room for the nut on the other side. I could also honestly just attach this with double-sided tape. It doesn't really need screws, but screws would probably last longer. Let's plan for that, maybe. So maybe a little wire channel that comes down the front is the way to do this. That's also something that affects this piece. I mean, it could be completely separate. I could just glue the wire down if I wanted to, but I think it'll be nice to have a better solution with the moving parts right here. Can we place this button just to get it out of the way? Because I think I know where it goes. Yeah. This might affect how the front panel, or the plastic enclosure rather, attaches, since, I want that to be sturdy for pounding on like that. And so the front panel is going to attach the button right here at the front. It's going to want to deflect inward, so maybe it wants to mount pretty close by. Or maybe even have pillars right there and right there that go into the plastic. That could be great. I might have to slide the nuts in sideways. Alright, let's keep that there. That seems fine. I was just imagining where the front of the case is going to be. The button sticks out a lot, but like this area right here is where the actual front hangs out. And you can see I can't really push it farther back very much anyway, because this cord is going to need some room to go up without hitting anything in front of it. So that's good. Can the motor driver just go right behind the motor on the gearbox side? How does this thing mount? 4 screws. Let's not worry about the motor driver until we have a spot for the microcontroller. So the microcontroller might want to go right there. That's right, I think. Oh. So if I go too far this way, then I start interfering with this, which isn't necessarily a problem in all cases, but it's easier if I can avoid that. Then there isn't really any benefit to not sticking out, at least as far as the spool here. So between this and any wiring I want to put above it, there's still plenty of room, given that the spool needs that space anyway. Granted, if I move this inward, then I can have the outside shell come in a little bit, perhaps. It does seem like this is going to want to be attached to the outer shell, doesn't it? Because also, this has network connectivity, right? And this is right up against the wall mounting bracket. So if this were in the plastic shell, then the plastic shell could actually come in here and have a spot for the cables to attach. So what I maybe want is for this to be attached to the plastic. Like that, maybe. So then the side of this will be pretty flat. Then there'll be a little turn in for the wiring. Maybe a little wiring strain relief doodad over here. And then the rest is taken care of for the wall mount. Yeah, and there doesn't need to be a lot of room here, because then you'll just take off the whole side of the robot. The wiring will be in there. I just need to make sure that if I do it that way, there's a good way to let the cabling stay far away from this moving assembly. So I think that means I want a way to run wires down from the top. Maybe I just have a little channel here, or even some little wire grabbers along that side. It doesn't matter which side this is on, there's more room on this side because that side has the mount for the vertical roller. And then I could do a similar thing with, because there's probably also some electronic parts that I'll need that aren't on here. Like I'll need a capacitor and diode at the very least to soak up the power when I decelerate the motor, and that would otherwise be going right back into the power supply. The wall adapter can't handle that, unlike something like a battery. So I'll have probably a big capacitor to temporarily store the extra energy until I can use it in this circuit, and a diode to prevent it from going back. And I'll have to test that to make sure the voltage on the capacitor can't get too high, and if it can, then I'll have to have another solution. Some kind of transient suppression diode or something. So maybe that means on this side, there isn't as much room for like this thing that sticks back where the cabling is going to come out, but maybe I can still have a spot for all the power electronics on this side. Let's just see roughly if that works. I think if this theory checks out and the electronics can mount to the shell, then I can shift my attention to how does the shell mount and not necessarily worry about the details of the electronics yet. I'm tempted to put it like right over here. See if that fits. I'm not too worried about providing really great ventilation for this heatsink, given the relatively light duty that it's going to be operating. I mean, placing it somewhere like this will give it a decent amount of just internal convection. I can add some vent holes if I needed to, but I don't expect the average power usage of this is going to be very high at all. But, you know, this is why I'm putting off the design of the shell. There are many question marks. Let's build the mechanicals and then try to drive it with the electronics, and then once all that's working, we'll know how the shell needs to be. That seems fine. Let's also provisionally stick this input jack somewhere plausible. This is very temporary, but just somewhere we might put that. I mean, now I wonder, do I put the power jack next to the network jack, or do I put the power electronics on one side and the low voltage stuff on the other side? I mean, it could go really nicely right over here. Might find a better place for that later. I don't know, that can also go on pretty much either of these sides without much worry. Let's try out the other place I was thinking. The other place was, well, basically relative to this, actually. Keeping these in a line doesn't really work. I could flip the board, but then the way I anticipate mounting this, which is screwed to the inside of the shell, doesn't leave me really room to work with the electronics. This would be better off over here. Does that even work? That would be a weird little L-shaped cutout, wouldn't it? Position either. I'll have to think about how the shell might mount. So there's a bunch of electronics that can go pretty much anywhere that's convenient. The shell is almost certainly going to want to mount like somewhere along here. You know, like these two sides, this side, and something equivalent to this. So let me maybe over here. And this, even though most of the electronics are going outside, having the analog amplifier right next to the load cell seems like a good idea. Okay, so I need bolts for the shell, I need wire management, and then I think these pieces are ready. So most of the wiring can be on the bottom side of this. So I've got network, power, and motor all down here. The stuff on top is just the optical encoder, which actually has kind of a big cable. It's not as big as it looks in this CAD model, but it is actually still pretty big. And then I2C for this thing, which is the HX711 A to D converter. Just thinking there could just be a channel in this piece that I could run the wires through. Now I'm deciding, do I want to add something on outside this, or do I want to just make a hole through it? I don't know, how much structure do I have in there still? So, just trying to analyze like how much of my front and back here are still solid. I mean, it's pretty solid except for that bolt right through the middle. We took off a little bit around here, but then we also added a bunch. I'm gonna measure the diameter of that cable for the, oh, here it is. The load, not the load cell, the optical encoder. That's about a 5mm diameter cable, which seems enormous for what it is. And then the end of it would probably need like a 7mm, no, like a 6mm hole. It would actually pass through pretty comfortably. Maybe a couple of 6mm holes. I don't know, let's go back to the frame and make a new sketch over here. So that's a 6mm hole. Trying to decide how much I care about making this easy to take apart. I mean, in general I care about making things easy to take apart, but I guess what I mean is if I run the wire all the way through that hole after assembling these two pieces, will that cause a problem? There's certainly an alternate strategy where I just have clips like near the bottom and near the top. And then the wire runs like along this surface. I think given how big the wire is and how much I kind of need it to stay away from that spool, I think actually giving it a hole to run through might be really nice. And so let's just cut a hole. Let's offset that to get some clearance. I think I would like this hole to be triangular. Does that fit this? I think it does. Alright, I don't think I need that anymore. I think we can just make this a right triangle. I don't want to measure any of that, I just want that. Okay. Just a couple millimeters. objects to cut, yeah. Both sides of the frame. That's what we wanted. Alright, I like that. It's a happy little place to put some wires. Symmetry would tempt me to put another one on the other side, but it would be unnecessary and it would only weaken it. So I kind of like this location. Let's add some screw mounts. What kind of screw can I even fit in there? I think those holes are a little small for M3, but I'd like to have M3s if they fit. Ryan asks, can you use a JST jack at the top board? It would make it easier to disassemble. If it fit through that hole, maybe. I mean, the problem is really the wire going through this hole. I don't know if I care enough to use connectors. Oh, these totally fit M3. Okay then. Maybe we'll do that. I mean, to make this fit, a connector would probably need to make it even wider, and I care more about having this be structurally sound than being able to put a connector through there. And the other ends of those will go to some kind of circuitry over here. You'll be able to take these two halves apart and then slide this down on the wire without taking anything off the other end. But taking this completely apart will require a little bit of soldering, probably. I'm okay with that. I think I prefer that to the alternatives I can think of, which include external kind of spring clippy things for the plastic, adding a cutout here to let the wires go through, but normally have them stay in. I like this because it just, there's no way the wires are coming out and getting stuck in the spool. Alright, so what do we have up here? I think this has got to use heated inserts. HX 711 breakout. Now I want to extract this from the... This is like a grab bag of stuff that I copied from the last revision of the design, but I would like to have a separate component just for the HX 711 mount. Okay, HX 711 mounting. I can move the breakout in there. Great. And now that I'm in this new component, I can just start filling it with parts without worrying about making too much of a mess. I think we want some like M3x8s. I was just getting sidetracked by debating between M3x8 and M3x10. Oh, fucking standard. Yeah, let's try M3x8. Whoops. I just want a model right now. I already have plenty of these. did this just go? Are you sure? Where did this go? I don't think it went anywhere. Okay. I don't know where that went before, but I got it back. Oh, was it inside the motor? I turned off the motor, I would have seen it. I know that's sitting inside the keep out region I set for myself, but I think it's actually fine. I'm just double checking that it actually fits. That gets really close to shorting out with a component, but I think it'll be fine. Worst case, it shorts out some, well, I guess it shorts out the bias voltage to an isolated plastic stud, so whatever. Yeah, I think that's fine. And then that looks good on the bottom. Do I already have a 3D model for an M3 insert? I remember using some on that VFD project. I should see where those came from. Alright, let's take a field trip over to the VFD project I did a little while ago to find out where the inserts came from. Maybe I didn't actually include the inserts. Maybe I just cut holes for them. That's fine. I think these holes were a tiny bit bigger than I really wanted them to be. 0.6. Yeah, let's just cut something a little smaller than that. So we're still in the HX711 mounting. Now we're going here. I'm going to use this to make standoffs that come up and meet the board, and also space for the inserts. The bottom of the board is flat everywhere except for the solders, like right over here and right over here, so I think I might try to support the board underneath over here. project. Okay, let's have something like 3-point. The size for the clearance hole and the size I want to use for the brass insert are actually really close. I might be able to just use one size for both. Should have made that circle construction geometry. I think I've got to make this a new body and then attach it separately. So that's like a little shim that should avoid the soldering area over here, but still provide a bit of a standoff. Then let's try this. Combine this with this. Okay, now we just need to deepen these holes. I'm making it a little deeper than it needs to be in case I need to use a larger screw, or just because the process with the heated inserts is a little easier if you have a little bit more depth to work with. I think that'll still be fine. Okay, so now I can go back to the frame. Now that's what it looks like. And so again, this will print this orientation. So that'll have support material in it. Actually, maybe it won't support that because it knows it can bridge. So that'd be nice. But okay, what are we down to? Just attaching the shell, right? The shell might end up being kind of asymmetric, because if there's a seam right down the middle, then that goes right through the middle of this button, which is not the end of the world, but it makes installing the button and installing the whole thing super annoying. So it'd be really good to avoid that. So instead, one side can be a little larger. still imagining the two sides go on left, right. That means the button needs to go on the side that isn't the microcontroller side. Otherwise... Oh, actually no, either way works. And making that the big side might have some advantages. Anyway, it seems like mostly I'm going to be dealing with bolts coming in the side, attaching like to this surface. I'm just thinking about this again. And it might be nice to have some way to attach directly to here. So maybe you put that shell in, and then there's some pillars in that side that attach here. Is this going to be a problem? I don't think so. And the wires can just run pretty much any way around there. See, imagine I'm printing one half of the shell, and this is oriented the way the printer is. I'm building it up. If all of the pillars that attach it to the central core point up, then they're easy to print. If I have any that point sideways, then I need to build support for them too. So most of them will probably point up, although it might be nice to have a sideways pillar or two right here. They could just come right up here, touching this surface, and then there could be a nut embedded in the back here. These are probably can just be M3 nuts. Okay, so we want to be in the frame component, which is where we are. I think I just want to start scattering around some nuts in interesting locations, and then add cutouts for those nuts. I think we'll want some there and there. Definitely like a few places along these side panels. Just the captive nuts sliding in sideways usually require a little bit of care for alignment, so they aren't the most foolproof way to assemble something blind, as you'd have to do with a shell. And I could do threaded inserts, like the heat press kind, although they're not very strong. At least not in PLA. Well, this might be a good time to wrap it up for tonight. It's getting pretty late here, and since I don't have a good solution for this in mind, maybe it's time to put this aside and work on something else until I have a good idea. This seems pretty close, though. Like, it would be really nice to get one of these prints started tonight. I mean, besides screw holes, you probably want this thing to have some way of locating. I mean, if you're just kind of like putting the sides of the shell on and without really any idea when the screws are going to fit in the right holes, it's going to be frustrating. Ideally, maybe the posts could have something they sit into, or maybe a ring around them, something along those lines. That still doesn't solve my problem where the nuts are in slots. Well, what if I don't attach the shell directly to this, but what if I make it easy to attach like a shell mounting bracket to this piece? That might have some other advantages too, because I can have all the attachments going vertically, so I don't have to cut any more holes against the grain here. And I can assemble that. And that would also give me a good place to add more stuff if I forget something trivial and I don't want to have to reprint this whole piece. So that means let's bring back some of our constraints. There's the motor. A little tight over here. I mean, here's the front. The front's probably going to need a little more support, given that the back I still don't entirely know what to do with the back. So I don't even know if the shell is going to cover this part, because this is actually load-bearing, like this will be pressed up against the wall. I'm curious what the parts so far look like in Cura. I mean, I'm mostly talking about the frame. We've already printed the gears and the spool. There's some new printable parts for these rollers, but they're all really simple. They're just cylinders, basically. And I can print them on the small printer pretty easily. But these are going to take a bunch of print time. Alright. It's not really ready to print yet, but it's nice seeing it in here anyway. Alright, 14-hour print it says. That's not too bad. That's pretty straightforward. Let's see how the other side looks. Oh, this piece ended up being complicated too. The other half is the side that attaches to the motor, but then this is the side that attaches to everything except the motor. That's right. 24 hours? Are we gonna hit 24 hours with this one yet? Hmm. 19 hours, not bad. Yeah, that'll be nice. Oh man. It is really tempting to just start printing these anyway on the assumption that there'll probably be some problems with them that I should find out. It's just with a piece this big, it's nice to at least have some hope that the piece will actually be usable when you print it. And we're pretty close to having something plausible. It just needs some mounting holes. This area is clear. Like, this area will be kind of taken up, but this whole area is clear. This whole back edge, but especially this part. Like there and there. This side's harder. Alright, well, I think I'm going to wrap up this stream. Thanks for joining me, and thanks for joining Tuco on this CAD adventure. We will have other videos and other content soon. Might be producing a little bit less than usual for the next couple days because my dad is in town and I don't get to see him pretty often. I have a pretty weird relationship with most of my family, but he's like the only part of my family that I still talk to, so it'll be nice to actually try that a little bit. As always, thanks for watching. Special thanks to everyone who supports the channel by contributing money every month with Patreon, by sending in hardware, by suggesting what they want to see, and just generally being supportive and giving good feedback and being good online friends, that sort of thing. All that helps. A little bit of cat for the end of the stream. He seems pretty passed out. It is late here. Ears twitching. Hey, buddy. Such cat. night, everyone. Happy hacking.